This is the Pearson Edexcel Ial, Mathematics P2, Pure Math 2. We're going to be looking at question 8 in this video, general solution of trig equations of trigonometry. Question 8, just instructions show all stages of working. Solutions that aren't based on some sort of calculator work won't be acceptable. Okay. So to look at the information, first thing, we're given this information. So it's going to be between minus pi over 2 and pi. And they want us to solve for this equation within those restrictions. So this is your restriction. First one's in radians, and then number II, if we look at it, is in degrees. So first one, you need your calculator in radian mode. Number II, the restriction is that it's going to be between 0 and 360 degrees. And then we have our equation there. Okay. Trig equations. First step is to try and get it in sort of either sine, cos, or tan. We don't want mixed up sine, cos, tan. That would be confusing. Next step is you want to get the sine stuff on one side. So we have everything that is attached to the sine, which is within the stuff within the bracket stays with it on one side of the equal sign, and everything else on the other side of the equal sign. So these extra bits, we want them on the other side of the equal sign. So if we minus 2 from both sides, and we will end up with sine 3x plus 0.1 in radians equals to -2. Those cancel out. And we still have the 5. Then we divide both sides by 5. And these two cancel out. So we get sine 3x plus 0.1 radians is equal to -2/5. Okay. Last step, we leave everything in the brackets where it is when you're getting your reference angle. And we take sine to the other side. Sine, inverse of sine is sine to the -1. So sine to the -1 cancels out the sine, and -2/5. So we have 3x plus 0.1 in radians is equal to -2/, not 3, 5. Okay. Oh, we're going to go into my general solution method. So my general solution method, we find a reference angle, and I always find a positive reference angle. So for a positive reference angle, we would take the positive sign for the -1 of 2/5. So shift sign 2/5. Shift sign gives you sine to the -1. I see in my calculator, I already made the most common error is that I didn't change to radian mode. So press mode, shift setup. Just to change to radians, shift setup. And then number 4 on my calculator. Number 4 puts it in radians. Okay, so do it again. Shift sign gives you sine to the -1, and we want 2/5. So our reference angle comes for sine to the -1 of 2/5 is what I'm doing in the calculator. So we get a reference angle of 0.411516846 just write down everything there and so on. This is in radians. Okay, but this was negative. So it's important to remember that this was a negative sign. So we're going to be looking at where sign is negative. If I draw my little sticker, I know that other people also call this the cast diagram, but since I start in quadrant 1, I prefer to use a sticker. Okay, a sticker. Let's do it like that. So we're looking at in radians now. So our first quadrant will be just our angle, which I'm going to draw as a theta. Our second quadrant is pi minus our angle. Our third quadrant is pi plus. And the fourth quadrant represents 2 pi, which is obviously a full circle, minus theta. So we want where we had a negative sign. Now, where is the sine graph negative? Well, the sine graph is negative not in the all section and not in the sine section. So it's in the third and fourth quadrant. That's where it's negative. That's where we're looking at. Okay. So we come back to this where we had kept 3x minus 0.1 radians together. So let's start with our second quadrant. So we're doing now first the second quadrant. So just a second quadrant. We're looking at all our options. Okay. Second quadrant, well, we know that 3x plus 0.1 must be equal to our pi, using this, plus our theta, and our reference angle, our positive reference angle is 0.411 and so on. So we add pi to our reference angle and it equals 3.553109.5. Okay. So looking at on the left here, why did I left everything in the bracket over here. Now we can see how these different parameters here affect things. So the first one you want to look at is the the 0.1. We minus 0.1 on both sides, minus 0.1 on both sides. So that affects just the left-right shift of our graph. So if we had a little sine graph drawn, this is we've shifted the plus 0.1 moves it not to the right, it's within this bracket, so it's counterintuitive, so it moves it to the left. It's been shifted by 0.1 radians a little to the left. Okay. This is not drawn to scale, but it's going to be shifted a little bit to the left. So if we minus 1 on both sides, this would be minus 0.1, sorry, not 1. That cancels out. And then we end up with 3x equals to 3.553109.5 and so on, minus 0.1. And the last step would be to get rid of the 3. So you divide by 3 on both sides. But just to take note that this parameter here affects the period of our graph. Now we're looking for the general solution. So that means that we're going to be plussing, n represents counting numbers, so or integers actually. It represents +1 or -1 or 0. That's how many times we repeat our repeating graph. So a sine graph repeats 1, 2, 3, and so on. It repeats infinitely. This is, I'm doing a full general solution. We'll have to come back to our restrictions at the end, but I'm doing a full general solution so you can see like all the possible answers it could be. So a sine graph in radians would be 2 pi. So this would be the full period of a sine graph is 2 pi. So 360 degrees is 2 pi. Okay. But this 3 affects the, well, let's take a look quickly. So if you have your parameters of a sine graph, let's say sine 2x was then this was, if your original sine graph ended in 360, your new one has been squished by a factor of 2. And as I said before, everything within these brackets, so everything attached to this x is the opposite of what you think. So it's counterintuitive. So counterintuitive, if it's a 2, it's been divided by 2. And if it's a half, it's been times by 2. So in this case, it's 360 divided by 2. So our new, if this was 360 was sine x, then our new period will be 360 divided by 2 will be 180. So for sine 2x, the period is 180. Okay. Or 2 pi divided by 2 is just pi. That's pi radians. Is also to do it in radians. So 360 is 2 pi. Little side information there. So that's what we're doing. And by this logic, you would have to divide your 2 pi also by 3, because the left-right movement doesn't affect your general solution, because moving it left or right shouldn't affect the period. So this period here has been moved to the left, but it's exactly the same period. If this was, for example, 180 or pi, then this one will also be 180 or pi. So it hasn't been affected. Okay. So just to see, those are the explanations of how we get the full general solution. So where were we? We got x equal to 3.55, or this is still in radians. So let's just check this. 3.5531095 minus 0.1, all divided by 3 should give us more or less 1.15. It gives us 1.15, and our general solution is n times 2 pi over 3, where n is an element of any integer. N is an integer. You have to write this. N can't be a bit of an integer. It has to be -1, 0, 1, etc. in either direction. Okay. Oh, that was obviously, this would usually go a little quicker, just all the explanations. I mean, we've only done quadrant 3, so now we have to do the quadrant 4. So this takes care of every possible answer connected to this x that was from quadrant 3. Now you just make sure that sometimes when you do quadrant 4, things double up, and sometimes it doesn't. So we have to just make sure. So very thorough general solution explanation I have. So we end up with 3x plus 0.1, and this time it's equal to 2 pi for quadrant 4. 2 pi with our quadrants, so we're doing this one. 2 pi minus theta. And our theta is if you remember, 0.411 and so on. Now we do the same thing again. So 2 pi minus 0.411. In the calculator, make sure you're in radian mode, 5.87166 and so on. Then we take 3x equal to that, so 5.87 minus 0.1. And then we divide both sides by 3, but remember that we're also dividing the repeating points by 3. Oops, so it still has a, sine graphs still have a period of 2 pi. Okay. And we end up with 1.92, rounded off, 1.92 plus n 2 pi over 3, where n is a integer, an element of an integer. N is an integer. I have to write this. So we've given all our possible options, but what we haven't done is checked our restrictions. So let's grab our restriction of the question. The restriction here is given in the beginning. So it's minus pi over 2, x not including and not including pi. Okay. So our restriction, minus pi over 2 to x not including pi over 2 and to pi on the right. That's our restriction. So we have so far, if we look at minus pi over 2, where does that get us to? Well, let's take a look. If you're like me, then you would have maybe been introduced to degrees before radians, in which case to change radians to degrees, sometimes it's helpful to use this. So to change radians to degrees, we have let's just use this example. So pi over 2, for example, times by 180 over pi will give you the degrees, which comes to 90 degrees. So this is to change, you take your radian and you times it by 180 over pi. And of course, this is reversible. So if you had a degree, you times it by pi over 180 in order to get radians. Okay. So if you suffer from blanking when not using degrees like I do, then we look at this is actually minus 90 to 180. Okay, we convert pi times 180 over pi just cancels out, so it's just 180. Okay, minus 90 to 180. So this is our restriction in degrees. And if I were to make a little drawing of that, so we've squished it by a factor of 3. And so we have a little baby graph. It hasn't been flipped, but it's been moved a little bit to the left. Plus 1 is to the left. So sort of, if here's it's not exactly accurate, but just to give you an idea, usually because it hasn't been flipped, the sine graph goes up, down. So up, down. And we're going to minus 90. So maybe somewhere here is minus 90. And then our 180, of course, it's been squished by a factor of 3. So it's not going to be exactly where we it would normally expect it to be. So if this was 360, we divide 360 by 3. It's now going to end on 120. So just to give you kind of a little idea of how that looks graphically. Now, you don't need to draw any of this in your answer if you can at all, just to give an idea. So we're going from minus 90 to, which is somewhere here, to 120. excuse me, 180, which is somewhere here. Okay. What does that mean for our general solution? Well, it means that some of it won't work. So let's get, this was X, these are our options. So we have, let's get our little options out. So we had X here. This is our full option if we had no restriction. Okay. And then our other full option if we had no restrictions. Okay. So these are our non-restricted options. And remember, our restriction is minus 90 to 180. So if we take, also minus pi over 2 to pi. So of course, if you use the converted one, you kind of have to convert this as well. So 2 pi over 3 times 180 over pi. If you want to convert everything, really see where you're going, 2 pi over 3 times 180 over pi is 120. So it's repeating, obviously that's 360 divided by 3, makes sense. It's repeating every 120. And 1.15 times 180 over pi is about 65 degrees. Okay, it's a little bit, it's 65.89 is the actual answer, but just to give an idea of where we are. And this one we can also do 1.15. If you are more comfortable with radians, just skip ahead to the end. This is about 110, more or less, 110 degrees. And 2 over 3 is N1 plus N180, 120, excuse me. There we go. Okay. So putting it in degrees just helps me to draw it out. So we have 65 plus N120 and, well, let's take a look at 65. So 65 is within the correct, it's within the parameters because we're going from minus 90 to 180. So 65 is good. So if we let n equal 0 over here, we end up with 0 times 120, 0 times 120. So that just becomes 0. So 65, this can be one of the answers. So 1.15 is one of the answers. Okay, 1.15 in radians. And if we let n equal 1, then we're adding another 120. So we're adding 1 times 120. So it's plus 1 times 120. 65 plus 120 is 185. So it's too far. Too far. Okay. Let's try just for the sake of it. If we let n equal minus 1, we're minusing 120, repeat. 65 minus 120 is negative 55. (65 minus 120, negative 55. Of course, we have to rechange this, so times it by pi over 180 to get it back into radians, and you get negative 0.955, because this one does exist. Negative 55 is within our parameters of minus 90 to 120. Okay, so negative 55 exists. Around 1.95. I just calculated a little bit more correctly. If you take to calculate that a little bit more correctly using the radians exactly, you'd say 1.15 minus 2 pi over 3. So this one, the second one, letting n equals 1 minus 1 exists. 1.15 minus 2 pi over 3 is more or less equal to 0.94. Okay, negative 0.94 in radians. Right. So as you can see, if we minus another, if we let n equal minus 2, we go too far. So this one's complete. So let's get it down. So we have two options for x from this one, from the 1.15 thing. So we have either x is equal to 1.15 or x is equal to negative 0.94 in radians. Those are our two options that came out of that first general solution within our restrictions. Now we can look at the other general solution we got. So this was the fourth quadrant information. Okay. Bringing it down a bit so you see it a little bit more clearly. Okay. That didn't work. Bring this all to here. Okay. So this, do the conversions and try to do it without the conversion. So this time, 1.92 plus n 2 pi over 3. And we're going from negative pi over 2 in all the way to pi, which so 1.92, if we let n equals 0, then we just have 1.92, and 1.92 is between negative 2 pi and pi, because, well, pi is equal to 3.14 something. So let's just check that. Yes, that works. Okay. And then if we let n equal to 1, then we have 1.92 plus 1 of the 2 pi's over 3. So just to, in case anybody's still confused, that's because of repetition. So that means we're looking at where x is 1.92, which could be somewhere on this graph. So let's put it maybe there. We want all the 1.92s within the, so it repeats again here. So this is plus 2 pi over 3 to there, and it keeps repeating. Okay, so we're plussing 1 2 pi over 3, and we know that at our y value that we're trying to get, it's going to hit more over and over again on the sine graph. So if we plus 1 2 pi over 3 to that, we go too far. But let's try, this is too far, 1.92 plussing by 2 pi over 3 is 4, which is more than pi. Okay, too far. Then we do letting n equal to minus 1, 1.92 plus minus 1 times 2 pi over 3. So that would be going on our graphic representation, going this way. And this gives us negative, more or less negative 0.17. Okay, which is it's within our, because it's within our restrictions. Pi over 2, if pi is 3.14-ish, then you divide that by 2, it's going to be 1 point something, and negative 17 is well within that restriction. So we have, in the end, 4 options for x. X is equal to, from the first two, it's equal to 1.15. And it was equal to negative 0.94. And then from the fourth quadrant, it was equal to 1.92, and also negative 0.17. Now that concludes the first general solution, the one in radians. Question 8 continues to II. Okay, so we have this time a much easier restriction. It's from 0 to 360, and we have a tan, sine, and cos. So we have a little bit of a harder equation, but thank goodness this one's in degrees. So let's take a look. 2 tan theta sine theta equal to 5 plus cos theta. So first thing we want to do is try and make this in either sine, cos, or tan. We don't want it in all three. We want it in one of them. So, well, tan straight away. Tan theta is equal to sine theta over cos theta. So we can immediately change tan to sine theta over cos theta. That sine theta is still there. Okay. Let's just simplify this a bit. So it's sine over 1. So it'll be 2 sine times sine, which is sine squared theta over cos theta, is equal to 5 plus cos theta. Right, that looks a little bit better. Now we have cos theta in the denominator. So we want to make an LCD, and we can choose our lowest common denominator as cos theta. So let's take a look. We'd end up with, this is all already over, it's one term, it's already over cos theta. So 2 sine squared theta all over cos theta equal to 5 cos theta times top and bottom by cos theta over cos theta, plus cos squared theta, cos theta times cos theta over cos theta. So we times top and bottom by cos theta. Okay. Now all the denominators are the same, we can drop them. So we have 2 sine squared theta equals to 5 cos theta plus cos squared theta. Looking good, looking good. Now we want it all in cos, I think. Can take it to either all cos or sine. But if you look at the Pythagorean identity, cos squared theta plus sine squared theta is equal to 1, then, well, it's quite easy to change this sine squared, by virtue of this, sine squared theta must be equal to 1 minus cos squared theta, and cos squared theta must be equal to 1 minus sine squared theta. So we can see that sine squared theta is 1 minus cos squared theta. We've accomplished one of our goals, and that's to get all of it into cos. Okay, so as times this 2 in, 2 minus 2 cos squared theta is equal to 5 cos squared theta. Whoops, daisies, plus cos. It's not a square, it's just a theta. Okay. Let's get this all on one side. I notice it's got, now we've got a probably going to have some sort of trinomial situation. So I always bring it to the right. 5 cos theta. Okay. We add 2 cos squared theta on both sides. It's going to be 3 cos squared thetas. The 5, there's no other cos squared theta, so 5 cos squared theta, cos theta. And then we minus 2 from both sides. So this cancels out, minus 2, and we're left with 0. Now we have a trinomial. So just to take a look at why is this still a trinomial? Well, trinomial, if we had if we had 3x squared plus 5x minus 2, that would be easily recognizable as a trinomial, that we're just changing our causes. This is a squared cos, and this is a 1. The requirements of a trinomial is that the first term is double the middle term and that there's a constant, okay? So we're good. This is in fact a trinomial. You can open up brackets as if to solve it out. Instead of x, we put cos theta. So just switched out the x for cos theta. 3 factors of 3 is just 3 and 1, so that works. Then we need to times together to get a negative 2, and it needs to add together to get the 5. So we look at what terms. So 2 has only got 2 and 1, so it's factors of 2 is just 2 and 1, or 1 and 2. Okay, that's it. So we could either put 2 and 1 or 1 and 2, and I can see, well, we want to make plus 5, so let's put it over here, 2 and 1. That means that makes plus 5. And if we had, that's a 6. Plus 6x minus 1x. How do I know one was plus and one was the other? Is because if the third term is negative, the signs will be different from each other within these brackets. So plus or minus, and the biggest one, the one that makes the 6x, will take the sign of the middle term, because obviously you want the middle term to be the positive or negative. It has to make the middle term when you add it together. So that means that we have a plus there and a minus there. Okay, plus, minus. So we have 2 brackets times together equals to 0. That means that one of those brackets has to be 0, because anything times 0 equals 0. Therefore, either of those brackets could be 0. 3 cos x minus 1 could be 0, or cos theta plus 2 could be 0. We have 2 options. We're nearly there to the general solution part. On this left one, we might plus 1 on both sides. We get 3 cos theta equals to 1. We divide by 3 on both sides, and we get cos theta equals to a third. On the cos equal to 2, minus 2 on both sides, we get cos theta equals to negative 2. Just take a look at this one. I can already see it's invalid because a cos graph looks like this, and its cos theta is y's, so its y's go from 1 to minus 1, and so therefore negative 2 doesn't exist. You can also put it in the calculator. If you get an error, then obviously it doesn't exist. So if you try to do cos to the minus 1 of minus 2, it'll say error. Okay, it's invalid. Can't do it. So we only have to work with this one. Cos to the minus 1, take cos the other side. So theta equals cos to the minus 1 of a third. Okay. Now we have a positive reference angle, which is the best place to be, because when we have a positive reference angle, it is in fact just the reference angle that we use. So you put this in your calculator, cos to the -1 of 1/3. And that's, oh, mine's still in radian mode. Of course it is. Change it back to degree mode. There's some shift setup. Number 3 for mine, degree. Okay, back into degree mode. Cos the -1 of 1/3. Okay, where were we? So our reference angle is 70.52877937. Okay, degrees. This is in degrees. So open up my sticker diagram that tells me where the cos graph would be in the negative or in the positive. And we see, well, cos is positive at A and C, so it must be negative at S and T. Oh, excuse me, we're doing positives this time. Okay, positive at A and C. So positive, this is just theta, and at C, it's 360 minus theta. Those are 2 options. We have a reference angle of 70. So we say that theta is equal to just 70. I'm at 70 points rounded to 5. 70.5 plus n 360, because there was no squishing it horizontally. We didn't change the graph in that anyway, left, right, squishing, stretching, none of that was happening. So it's just the normal cos graph, which has a period of 360 before it repeats again. So that's our first general solution. And remember, is NES. N must be an element of an integer. And then we do our second option. So theta can be 360 minus our theta, which is our reference angle, 70.5. And 360 minus 70.5 is 289.5 degrees, and plus n 360. Okay. Now remember, these are all our possible options. There's every single option, and we don't want every single option. We had a restriction. Go, whoa, what's going on here? Grab our restriction was theta is between 0 and 360, not including 0 and not including 360. So our theta is between 0 and 360. That's our options. Okay, kind of easier to see it in the, at least for me, kind of easier to see it in the degree mode. Here we go. Let's take a look. So 70.5 is definitely within, it's correct. So 70.5 exists. Theta is definitely going to be equal to 70.5. And if we plus 360 to 70.5, it goes further than 360. So that's the only one. Then we look at 289.5. That exists. It's definitely bigger than 0 and smaller than 360. So that exists. And if we plus 360, it goes too far. And if we minus 360, it goes under 0. So it goes too far. So just these 2 options. Okay, that concludes the general solutions. Trigonometry, question 8. Good.